In the world of engineering, some heroes are unsung, their roles vital yet often overlooked. One such marvel is the pressure relief stack. Now you might be wondering, what is a pressure relief stack? And why is it so important? You see, in many industrial processes, pressure is a constant companion. It's like that friend who's always there, sometimes welcome, sometimes not so much. But unlike that friend, pressure isn't something you can simply ignore when it becomes inconvenient. If left unchecked, pressure can lead to catastrophic failures in systems and equipment. That's where our unsung hero, the pressure relief stack, steps in. Imagine it as a sentinel, keeping a watchful eye on the pressure levels, ready to intervene when things get out of hand. It's the safety valve of an industrial process, ensuring that pressure doesn't rise beyond a certain threshold, thus preventing potential disasters. But the pressure relief stack isn't just a guardian, it's also an embodiment of ingenious engineering. It's a testament to how human ingenuity can transform a simple concept, pressure relief, into a sophisticated solution that safeguards countless industries worldwide. From chemical plants to power generation facilities, pressure relief stacks play a pivotal role, often unnoticed but always indispensable. Let's not forget the challenges that come with designing these marvels. Material selection, sizing, integrating them into complex systems, these are just a few of the hurdles engineers face. Yet they overcome these with remarkable solutions, each more innovative than the last. Finally, pressure relief stacks are more than just feats of engineering. They're also a testament to our commitment to the environment. Engineers constantly strive to minimize emissions and waste from these stacks, ensuring they meet stringent environmental regulations. So the next time you see a towering stack in an industrial setting, remember, it's not just a stack. It's a marvel of engineering, a guardian of safety, and a testament to human ingenuity. It's the unsung hero that makes the world of industry tick. So what exactly is a pressure relief stack? Let's delve deeper. Having understood what pressure relief stacks are and their importance, you might be curious to know how exactly they work. It's truly a marvel of engineering, a blend of science and innovation that perfectly illustrates the magic of human ingenuity. So let's take a look under the hood of these unsung heroes. Pressure relief stacks, at their core, operate on a simple principle. They provide a controlled outlet for excess pressure. Think of it as a pressure cooker. When the pressure inside the cooker rises beyond a certain point, the safety valve opens, releasing steam. The pressure relief stack functions similarly, but on a much larger and more complex scale. When the pressure in an industrial system rises beyond a safe limit, the pressure relief valve on the stack opens. This valve isn't just a simple door that swings open, though. It's a meticulously designed component, calibrated to respond to precise pressure levels. When the pressure hits the designated threshold, the valve opens, allowing the excess pressure to escape through the stack and into the atmosphere. Once the pressure drops back to safe levels, the valve closes again. But the magic doesn't stop there. The released gases often contain potentially harmful substances. To minimize environmental impact, engineers design these stacks to include emission control systems. These systems treat the escaping gases, reducing their harmful effects before they're released into the atmosphere. It's worth noting that these stacks aren't one-size-fits-all. They're tailored to the specific needs of each industrial process, taking into account factors like the type of gases involved, the pressure levels, and the environmental regulations in place. This customization is a testament to the adaptability and versatility of engineering solutions. So, there you have it. The magic behind pressure relief stacks, the unsung heroes of the industrial world. They're not just towering structures in the backdrop of an industrial landscape. They're the guardians of safety, the protectors of the environment, and the epitome of engineering ingenuity. In the world of engineering, problems often lead to innovative solutions. The pressure relief stack, in its quiet way, is one such innovation. It's a marvel of engineering that stands tall, often unnoticed, quietly ensuring the safety and efficiency of industrial operations. A pressure relief stack is a safety device designed to release excess pressure from a system. It's like a guardian, always alert, ready to spring into action when the pressure rises beyond safety thresholds. It's a testament to the ingenuity of engineers who have designed an effective, reliable solution to a potentially dangerous problem. These stacks aren't just about releasing pressure, though. They're about doing it in a way that's safe, controlled, and environmentally responsible. They're designed to respond to precise pressure levels, opening to release excess pressure, and closing once the pressure returns to safe levels. This isn't a simple task. It requires a deep understanding of the physical properties involved, a keen eye for detail, and a commitment to safety above all else. And the beauty of these stacks is their versatility. They're not confined to a single industry or application. They're used across various industries from chemical plants to power generation facilities, each with its own unique set of challenges and requirements. This showcases the adaptability of engineering solutions, the ability to tailor designs to meet specific needs, and the commitment to continuous improvement. So the next time you see a towering structure in an industrial setting, remember the pressure relief stack. It's an unsung hero of engineering, silently working to keep systems safe and efficient. From chemical plants to power generation facilities, these stacks play a pivotal role across industries. They're a testament to the power of engineering ingenuity, the potential of human innovation, and the importance of safety in an ever-evolving industrial landscape. Like all technologies, pressure relief stacks come with their own set of challenges, but engineers are rising to the occasion with a keen eye on the environment. Let's delve into some of these challenges and the innovative solutions being developed to address them. Firstly, let's consider emissions. When a pressure relief stack does its job, it releases gases into the atmosphere. While this is necessary for safety, it can contribute to air pollution and climate change. But fear not, engineers are already on the case. They're working on innovative ways to capture and recycle these discharged gases, turning a potential problem into a sustainable solution. Secondly, there's the issue of noise pollution. High-pressure releases from pressure relief stacks can generate a lot of noise. This isn't just a nuisance. It can also have negative effects on the health and well-being of people living and working nearby. To combat this, engineers are developing noise reduction technologies. Think acoustic blankets and silencers that can absorb sound energy and reduce the noise generated by pressure releases. Thirdly, we have waste management. Maintaining and repairing pressure relief stacks generates waste, from old parts to used lubricants. Once again, engineers are stepping up to the challenge. They're working on designs that reduce waste and promote recycling. For instance, they're exploring the use of environmentally friendly materials that can be safely and efficiently recycled. As we continue to innovate, the pressure relief stack remains a testament to human ingenuity in the face of complex challenges. It's a symbol of our ability to adapt, to improve, and to find solutions that not only meet our needs, but also respect our planet. So the next time you see a pressure relief stack, remember not just the engineering marvel that it is, but also the ongoing work to make it even better, for us and for future generations. In the heart of our industrial world, the pressure relief stack stands as an unsung hero, silently ensuring safety and efficiency. These towering structures are the guardians of our infrastructure, playing a pivotal role in managing pressure buildup and protecting our systems from disasters. They are the invisible line of defense, the silent custodians of our modern world. But their influence extends far beyond safety. Pressure relief stacks find their place across various industries. From power generation plants to chemical refineries, they are integral to many processes that drive our world. In the energy sector, for instance, they help regulate the pressure in natural gas pipelines, ensuring a steady and safe supply of power. In the chemical industry, they are critical in preventing potentially catastrophic reactions due to pressure buildup. The role of these stacks is not confined to just one industry, but spans across a multitude of them. Yet, like all heroes, they too face challenges. As we've seen, the environmental impact of pressure relief stacks is a complex issue, one that engineers are working tirelessly to mitigate. It's a constant balancing act to ensure the safety and efficiency of our industries while minimizing the impact on our environment. But as we continue to innovate and push the boundaries of engineering, we are finding new and exciting solutions to these challenges. So the next time you come across an industrial marvel, remember the hidden heroes like the pressure relief stack. They might not be in the spotlight, but their role is crucial in shaping our world, making it safer, more efficient, and more sustainable. And that's something worth celebrating. From the steam engines of the Industrial Revolution to the complex industrial systems of today, the management of pressure has always been a crucial aspect of engineering. This is a journey through time, a testament to human ingenuity and resilience. In the early days, pressure management was a daunting task. The technology was rudimentary and the risks were high. Yet, engineers of the past rose to the challenge, developing the first pressure relief devices. These were simple in design but effective in function, providing a much-needed safety measure for the burgeoning industrial sector. As technology advanced, so did our understanding of pressure and its management. Engineers began to design more complex and efficient pressure relief systems, eventually leading to the development of the pressure relief stack. Yet, the journey doesn't end there. Today, we are on the cusp of a new era in pressure management. With the advent of digital technology, engineers are now able to monitor and control pressure in real time, providing an unprecedented level of safety and efficiency. And as we look to the future, we can only imagine the innovations yet to come. Perhaps we will see the development of smart pressure relief stacks, capable of self-regulating and adapting to changing conditions. Or maybe we will find entirely new ways to manage pressure, ones that we can't even imagine today. But whatever the future holds, one thing is certain. The pressure relief stack will continue to be a vital part of our industrial landscape, an unsung hero ensuring the safety and efficiency of our world. Pressure, an invisible force that can build up to catastrophic levels if not properly managed. This is where our unsung hero steps in. So, what is pressure exactly? In scientific terms, pressure is the force applied perpendicular to the surface of an object per unit area. It's like the concentrated force of a million tiny particles all pushing against a surface at the same time. Now imagine that surface is the inside of a pipe or a tank in an industrial setting. As more and more particles push against the walls, the pressure builds up. And what happens when pressure builds up? Well, it's like blowing up a balloon. As you blow more and more air into it, the balloon expands, but there's a limit to how much it can expand. Keep going, and eventually, the balloon will pop. The same principle applies to pressure in a closed system. If the pressure isn't released in a controlled manner, it can lead to catastrophic failures, such as explosions or system breakdowns. But here's the thing. In many industrial processes, pressure isn't just an unwanted side effect. It's a necessary part of the process. Whether it's in a chemical plant, a power generation facility, or a petroleum refinery, pressure is often used to drive reactions or generate energy. So the challenge isn't to eliminate pressure, but to manage it effectively. And that's where the concept of pressure relief comes in. The idea is to provide a controlled outlet for excess pressure, preventing it from building up to dangerous levels. It's like having a safety valve on a pressure cooker. When the pressure inside the cooker reaches a certain point, the valve opens, releasing steam and preventing the cooker from exploding. But how does this translate to an industrial setting, you might ask? Well, the principles are the same, but the scale and the complexity are much greater. And the solution? That's where our unsung hero, the pressure relief stack, comes into play. And so, to keep systems safe and efficient, engineers have developed an ingenious solution, the pressure relief stack. In the world of engineering, problems often lead to innovative solutions. The pressure relief stack, in its quiet way, is one such innovation. It's a marvel of engineering that stands tall, often unnoticed, quietly ensuring the safety and efficiency of industrial operations. A pressure relief stack is a type of safety device that's designed to release excess pressure from a system when it reaches a predetermined level. This excess pressure, if not properly managed, can lead to catastrophic failures. The stack acts as a safeguard, releasing this pressure in a controlled manner to prevent any potential disasters. The design of these stacks is a testament to the ingenuity of engineers. They are strategically placed within the system and are designed to handle specific pressure levels. The stack's size, shape, and materials are all meticulously chosen to withstand extreme conditions and to efficiently release the buildup of pressure. The operation of a pressure relief stack is a symphony of physics and engineering. When the pressure in a system exceeds the set limit, the stack's valve opens, allowing the pressure to be safely vented. The valve then closes once the pressure returns to a safe level, ready to spring into action again if needed. But the genius of these stacks isn't just in their design and operation, it's also in their versatility. They are used across a wide range of industries, from chemical plants to oil refineries and power generation facilities. In each of these settings, they play a crucial role in maintaining safety and preventing potential disasters. It's worth noting that these stacks are not a set-it-and-forget-it solution. They require regular maintenance and testing to ensure they continue to function correctly. Engineers are constantly monitoring these stacks, ensuring they are ready to respond when needed. So, the next time you see a towering structure in an industrial setting, remember the pressure relief stack. It's an unsung hero of engineering, silently working to keep systems safe and efficient. From chemical plants to power generation facilities, these stacks play a pivotal role across industries. Like all technologies, pressure relief stacks come with their own set of challenges. but engineers are rising to the occasion, with a keen eye on the environment. Pressure relief stacks, while pivotal to safety and efficiency in various industries, can have significant environmental impacts. The primary concern is emissions. When a stack releases excess pressure, it often discharges gases and vapors into the atmosphere. These emissions, depending on their composition, can contribute to air pollution and climate change. Engineers grapple with these challenges, constantly seeking ways to minimize emissions and ensure that pressure relief stacks are as environmentally friendly as possible. One approach is to capture and recycle the discharged gases, turning a potential pollutant into a resource. Another challenge comes from the noise pollution generated by the high-pressure release. Engineers are developing noise reduction technologies to tackle this issue. Innovations like acoustic blankets or silencers can help muffle the sound, reducing its impact on nearby human and animal populations. Waste generated from the maintenance and repair of pressure relief stacks is another aspect that engineers are addressing. They're working on designs that reduce waste and promote recycling, using materials that are easier to dispose of in an environmentally friendly manner. But it's not just about mitigating the environmental impact. The future of pressure relief stacks lies in continuous innovation. Research is ongoing to develop advanced materials that can withstand even higher pressures and temperatures. Engineers are also working on smart monitoring systems that can predict when a stack needs to release pressure, reducing unnecessary emissions. These innovations are driven by a combination of regulatory pressure, corporate responsibility, and a genuine commitment to sustainability from the engineering community. It's a tough balance to strike, but as we've seen, engineers thrive on challenges. In the grand scheme of things, pressure relief stacks are just one part of the vast, intricate world of engineering, but they serve as an excellent example of how engineers are striving to make industrial processes safer, more efficient, and more sustainable. As we continue to innovate, the pressure relief stack remains a testament to human ingenuity in the face of complex challenges. So there you have it, the pressure relief stack, an unsung hero of engineering, ensuring safety and efficiency behind the scenes. It's a marvel that can go unnoticed, yet its influence is profound in the industrial world. Through our journey today, we've delved into the captivating world of pressure relief stacks and their impact on various industries. We've seen how these ingenious devices play a crucial role in managing pressure buildup, ensuring the smooth running of systems and protecting them from potential disasters. We've explored the science behind pressure and how it can be both a useful tool and a formidable foe in industrial processes. And we've learned how engineers use their knowledge and creativity to harness the power of pressure, designing relief stacks that can withstand extreme conditions and maintain system safety. We've also looked at the diverse applications of pressure relief stacks across various industries. From chemical plants and refineries to power generation facilities, these devices are key to maintaining operational efficiency and preventing accidents. Safety measures associated with pressure relief stacks were discussed, emphasizing the importance of regular maintenance and testing. After all, these devices are a line of defense against catastrophic system failures. We've touched upon the engineering challenges involved in designing pressure relief stacks, a task that requires careful material selection, accurate sizing, and seamless integration into complex systems. And we've considered the environmental impact of these devices and how engineers strive to minimize emissions and waste in compliance with regulations. We've heard from experts in the field, gaining insights into the design, implementation, and maintenance of pressure relief stacks. And we've celebrated success stories, instances where these devices have averted potential disasters and proven their worth. And finally, we've peeked into the future, discussing ongoing research and innovations in pressure relief stack technology. The quest for advancements in materials and monitoring systems continues, promising even greater efficiency and safety in the years to come. Next time you come across an industrial marvel, remember the hidden heroes like the pressure relief stack. Don't forget to like, share, and subscribe to our channel, Brainiacata, for more fascinating insights into the world of engineering.